Good afternoon and welcome to this Future Tech Week session entitled A Female Perspective on Robotics and Information Technology. My name is Sarah Kiehne and I, along with my colleague Erich Prem from Oitema, we are members of the FETFX consortium. Today we are speaking with two impressive women from EIC Pathfinder FET projects. Professor Cecilia Laschi from the BioRobotics Insitute of the Scuola Superiore Sant'Anna in Pisa was the coordinator of the FET Proactive Project Octopus, which ran from 2009 till 2013, and Professor Clivia Sotomayor Torres from the Catalan Institute of Nanoscience and Technology, who also happens to be a former co-chair of the Future and Emerging Technologies Advisory Group and coordinator of the FET Open Project PHENOMEN, which ran from 2016 until this year. Welcome to you both, and thank you for joining us. So I will launch right into our questions then. I'll start with Professor Laschi. Perhaps you can give us a brief description of the Octopus project, highlighting some of the challenges it addressed, the results and the impacts. Also, have you been involved in any other notable FET projects?
Octopus is really my heart because it was a very interesting project for me. I'm a roboticist, and at that time I decided together with colleagues to study the octopus as a model for robotics, and that was quite unusual at that time because an octopus is completely soft, so completely different from a traditional robot. And then the challenges were so many because we had to learn a lot about the biology of the animal. And then we had to translate the principles that we discovered, and that part was very, very interesting. But those interesting principles had to be transferred to engineers. So we had to develop the technologies for building a robot that was soft, that could contract, that could elongate an arm and things, strange things like those. But actually, it worked a bit. We demonstrated at the end of the project that it was possible. We built a few prototypes, and especially we developed a lot of knowledge and new technologies that were at the base of what we call today soft robotics. So the impact in this sense was enormous because today there is a large community, a large scientific community around this field. Robotics that for me it was very much nurtured by the Octopus project.
Great, that's really interesting. And Professor Sotomayor Torres, please tell us a little bit about PHENOMEN as well as any other FET projects of note that you've been involved with.
Okay, PHENOMEN was a journey of discovery in many ways. I am passionate about the physics of lattice vibrations or phonons, and for some time I've been harboring the hope that we could use phonons for information technology in general, particularly information processing. And I met these like-minded people, and we decided to say, right, let's build a circuit, but not one that works at 10 millikelvin, one that works at room temperature. And not that one that works with poisonous materials or expensive materials, but straight silicon. And these were the boundary conditions that we set. We generated various concepts for particular enhanced functions that would give us properties that could be harnessed into a device. So in this project, we managed to build, design, etc., and demonstrate a phonon source, a phonon detector, a phonon switch, and all was based on the interaction of phonons and light. Phonons are rather elusive, although they are ubiquitous, they are everywhere. And what was very important for us was to have an interaction like that between lattice vibrations and light, electromagnetic radiation, that would allow us to understand what was going on and point us in the direction of building a circuit with minimum losses and that could perform information and communication technology functions. And thanks to an extension of 6 months, we managed to do that just in the last 4 weeks of the project. So,
so just in time.
perfect timing. So we recorded the video with the experimental results as they were coming out of the lab. Mm-hmm. And we received the news that we had lockdown in Spain from the next week. So it was, oh God, just everything on time somehow. But it was fascinating. And what really was very good and very encouraging and gave me a lot of hope in the future is the commitment of the young researchers. Mm-hmm. It was amazing. They were involved day in, day out. They were prepared to take extra work and participate in events like the ICT in 2018. Mm-hmm. They made beautiful graphics. They prepared presentations. They had the courage to present their work in front of the reviewers that we had for our project. I said, no, mm-hmm. Of course you can. And this is part of our job. It's also not only to push the science, but also to train the next generation as well. Mm-hmm. And this experience I have also had in other projects. Before FENOMEN, I coordinated a project of FET energy. Mm-hmm. That was called Merging, and it was based on membranes, on silicon membranes for energy harvesting, which actually laid the foundations for FENOMEN in many ways. Before that and other projects, but I think Merging was a stepping stone towards mm-hmm. FENOMEN. And FENOMEN is a stepping stone for other things now.
That's great. Okay, so tell me a little bit, like, how would you describe the innovation potential from FENOMEN? The project has very recently ended, so are there some new projects that were going to be related that are on the horizon, or some other transition to innovation activities that are planned?
I think our consortium was very aware of the FET Launchpad, mm-hmm. and so in particular one partner who is very oriented towards devices for technology, mm-hmm. Found a match in an SME, mm-hmm. and they decided to apply for a FET Launchpad project, which they got. Mm-hmm. So they will be working on oscillators to read radio frequency signals based on the radio frequency coupling we use in FENOMEN. So that is one success story, I would say. Mm-hmm. There is a business plan. It's all very clear. I think they have a very high probability of success there. And obviously, there were many questions left open, and they were worked into proposals that were submitted in the last round. So there are 2 or 3 proposals that came out of FENOMEN by different consortium members with other consortium members or with other new partners, which is perfectly fine. So,
that's great.
So I'm very happy with that, yes.
Great. So Professor Laschi, Octopus ended in 2013. Can you tell us a little bit about some of the developments that have happened since its conclusion?
Sure. I mean, I agree with Clivia a lot about the training of young scientists in this project, which is really, I think, the strongest value of our mm-hmm. results. In terms of innovation, I was not as lucky as Clivia, because the launchpad was not there yet at that mm-hmm. time. So I couldn't apply for that. And actually, I found a gap between the results from such, how can I say, basic research, fundamental research project like an Octopus. So we ended up after 4.5 years with a prototype of an Octopus-like robot, but it was really a demonstration that it was possible to use mm-hmm. software. It was, I mean, just a demonstration that it was possible. We could investigate more about soft materials in robotics. But from there to other kind of projects where you have to address some application or you have to integrate a real system, there is a gap. So we tried to submit proposals, but they weren't accepted because it was too early for that. Fortunately, actually, we could go on with some funding, and we went on developing our technologies, and the field grew, so many technologies became available all over the world. And suddenly we found an interest directly from companies. Companies interested in applying our let's say Octopus-like robots, but with the time, along the time, it was not no more Octopus-like. I mean, the important is the technology, the soft robotics technology. So the soft actuators, this kind of robots that can stretch, that can change shape, that can be soft in the interaction with people. And we found the interest of some companies, and we had also directly some funding from companies. Of course, the field of applications for a soft robot are so many. The biomedical field is one of them. You can think of soft arms assisting people. And there we had a project funded by the European Commission. The same in surgery, endoscopy. In endoscopy is very useful to have something soft that can move. So we also find interesting applications underwater, because we learned a lot from the octopus about locomotion and manipulation underwater. And also in the oil and gas companies, for example, so what is related to exploration, monitoring, and last but not least, we are now finding a lot of interest in those people and company monitoring the sea bottom. So it can be for the industry, it can be for ecology, can be for biology, can be for climatology, oceanography. So really many applications are coming up today, and the same for the single technology.
Thanks to both of you. I think this is really interesting to see how many different applications and you're mentioning, and how many areas this is opening. So I'm sure you are aware of the Commission priorities, you know, ranging from the Green Deal to the digital age, and Europe's fitness for the digital age, and others. May I ask you, what's the relation of your research to these priorities, if any? And maybe Professor Laschi, if we can start with you.
Yes, I started from the last thing I mentioned, that is the application of our soft robots underwater. There, I think we can contribute a bit to the Green Deal priority, because in two ways, actually. One way is what I mentioned, so we can build robots that can help in monitoring the environment. Because we can help robots that can move autonomously in different environments, even underwater. And that's one part of the story. So we can, I mean, provide them with sensors. They can measure a lot of parameters that are of interest for ecology, for the environment. But on the other side, using different materials for building our robots, we are also investigating materials that are more compatible with the environment, so eco-compatible or even biodegradable material, especially when we work at sea. I mean, we realized very soon that we couldn't put in the water of the ocean a robot which is made of materials that are not completely compatible. They can be dangerous for animals if there are dispersion of substances. So that's something that we are feeling very strongly today. And so we started a new research in our group about biodegradable materials that can be used for marine robots, so that we can even think of robots that can be sort of disposable at sea without hurting the environment. And I think that this is a strong concept that if it is used also in other fields of robotics, but also in other fields of technology, just think of the digital technology, the smartphones that we are producing and wasting today. If you can use something, some materials that are more compatible with the environment, that would have an enormous impact. And since I work on robotics, so I build robots, of course, my research also relates to other priorities that concern more in general the economics related to the jobs and occupation. Of course, when I say the word robot, the first question I receive is that, okay, but are you stealing jobs in your... What I personally think is that robotics is instead can be very great source of occupation, especially in Europe, because in Europe, I mean, we are quite strong in the robotics industry. So, but again, we are thinking of a new generation of robots. So I think that what we should do with these new materials, with these new abilities that our robots have to go and explore environment, to access difficult environments, is not for replacing humans in jobs that I mean, bring them salaries, but replacing humans in those jobs that are inhumane, if you want, and there are many of them. So again, robots that are more compatible with the environment, that are more able to access the environment, to be autonomous there, and even more compatible with society and with our society and with our economy, the economic model that we have today. And I think it is possible with this new generation of robots.
Thank you, Professor Sotomayor. I guess the priorities of the Commission also go nicely with your project, don't they?
Of course. For example, in the Green Deal, there is a lot of emphasis on the efficient use of energy, and also in perhaps even reducing the amount of energy that we use. And the information carriers that we are proposing, the phonons, are in fact one of the lowest energy information carriers. And in that sense, there is a potential there to minimize or to reduce the energy consumption in the ICT sector. Not in 5 years. I mean, I think we're looking at like 15 or something like that. At the same time, there is also the prospect of using this knowledge to harvest energy using phonons via thermoelectricity, via vibration, via piezoelectricity, even mediated by phonons. So in that sense, we have, I think, the underlying knowledge is being structured to go towards a solid development and support the Green Deal. Concerning the digital age, I think many of the aspects that are being pursued, 5G and 6G, etc., they will require autonomous systems. And autonomous systems need not only to work on their own, but also to feed themselves with energy on their own. And there again, this energy factor is going to play a significant role. The edge computing devices also need to be in many ways autonomous. That's the whole idea, is to decouple them from the centralized cloud in many ways. So again, using phonons interacting with electrons, phonons interacting with photons, phonons interacting with magnons, that would enhance the palette of resources, technological resources, to support the digital age as well.
Right. Maybe Professor Sotomayor, because you alluded to it a little bit, you mentioned this long-term nature of FET, and you know, of course, that FET is a special funding scheme. It has been around for 30 years. It's research beyond what is known. But it has a technological objective, even if it's long-term, so it's kind of special. mean, what are the characteristics of this scheme that are important for your research? And what are some features of the, let's assume, a fully fledged EIC Pathfinder initiative that you feel positively about?
I think what we've learned in FET over all these decades has been that the value of consortium-based research with a layer of multidisciplinarity, with a layer of various generations, the senior professors down to the master students, is an incredibly rich pool of ideas, practical ideas, implementations. It is something you do not find just in a single research group, unless you run a group of 50 people perhaps, and all with different skills. But then again, it is important to have deep knowledge in your area that you can share with people who have deep knowledge in their areas, because that's the only way, in a sense, to make progress, solid progress, sustainable progress that will yield something more imaginative, more useful, and in the future. So for me, those characteristics of consortium-based, which basically means, according to the conditions of the European projects, has meant 3 teams from at least 2 or 3 countries. I never remember the numbers exactly, you always have to go back, but it requires this different way of doing things, because the diversity in Europe is incredibly rich in that respect. The different ways of arriving at a conclusion or formulating a question, and that alone, I think, as a mechanism, is extremely, extremely important. Yeah. So for me, FET remains the most valuable instrument that my generation has had over the last 30 years. And I think it will be important to transfer some of these principles, these operational principles, to the future or the actual European Innovation Council. I have a lot of hope in the European Innovation Council. I think it's a new facet, but I think that research at TRL 1 level must be done also in a consortium, not only by solo researchers like in the ERC.
Thanks. I'm sure Professor Laschi, you have an idea about that as well.
Yes, exactly. I fully agree with Clivia. And what I really love in FET is that it's the place where you can really start completely new ideas, new research field. And when I say completely new, I mean completely new, because many other programs claim that they fund basic research, fundamental research. Okay, that's one thing. But in fact, you can really try and submit a completely crazy idea where you don't have any expertise. This is an important point in my opinion, because sometimes, as I said, also compared to other programs, of course the CV of the proposer also counts, but in that way you always bring back the research to the expertise that is already there. So if I must be credible in what I propose, it means that I'm going to do something incremental with respect to my own expertise. The Octopus is a perfect example for me, because before Octopus, my research was in humanoid robotics. And humanoid robots are rigid, they have joints, you can count them, and you have a number of degrees of freedom. And of course, it can be more or less complex to control them, but that's the story. When I proposed the Octopus, I didn't know anything about the animal, and I didn't know anything about materials. I didn't know anything about the soft actuators. Of course, I had started some preliminary studies by myself in my group. I had contacted the biologist, as Clivia mentioned. That's a very valuable part of the story, because I could match with all these people. It required a lot of time to prepare the project, because it is a way to start the research, connecting with the right people, learning the important things to start. And when I proposed the Octopus, you know, I sent this project and I said, okay, it's a completely crazy idea. I'm not credible because I'm a roboticist and a computer scientist. So either they will look at it and throw it away laughing, or they will fund it. And fortunately, it was the second. Actually, this risk that FET took at that time was very rewarding, because as I mentioned today, there is a wide scientific community working in soft robotics, and everything starting with that. And the FET program also funded a coordination action that helped consolidating this community. And it's a pity that, as I mentioned, sometimes there is a gap and you cannot go really much further than this, because Europe invests through FET in this new field with a lot of potential reward, and then should be able to take also the results of that, the fruits of that.
Great. So Professor Sotomayor Torres, you were actually the co-chair of the Future and Emerging Technologies Advisory Group. Can you tell us a little bit about your experience in this role?
Yes. First of all, it was a really valuable experience. I consider myself privileged for having worked with highly esteemed scientists whose number one priority was emerging technology in Europe. Also working with extremely committed members of the unit, of the FET unit. I think the knowledge one gains, the development of new ideas, of trying to find and identify which topics may be suitable for initiatives. This was a tremendous challenge. I think most of the time we managed to propose something sensible in sense of coherence, because sensible in terms of the knowledge perhaps is still open. I found that the cooperative spirit was tremendous, the level of commitment of everybody. And these feel as a unifying European experience was very important for me, not at the level of implementing a research project, but implementing discussions to go into documents that could be perhaps considered by the Commission when they decide on their policies. I had just the impression that several times there were things that looked like fait accompli, that one could try to perhaps modify a little bit, but the core decisions in terms of core policy, of course, they are made by the Commission. And we try to simply modify it and leave room for basic research, oriented basic research, or translational research, whatever adjective you choose. For me, is all technology readiness level 1. One important aspect was the discussions that I learned a lot from concerning the role of the social science and humanities. And for me, this has been now during this pandemic has become so apparent, the need to have this understanding. And perhaps this is something we don't do enough. Perhaps there is some reluctance from the social science and humanities. Perhaps we are not doing things in a way that they can be truly involved. Perhaps we need a new generation of social scientists and humanists that can talk to our younger colleagues, because clearly people of my generation, we are pretty set in our ways, even if rationally we want to, we lack the skills or the ideas to approach the social sciences and humanities in a way that they can become truly involved. This pandemic is opening an enormous opportunity as well. To solve many of the problems, we cannot ignore the social science humanities. We have economics, we have psychological issues, we have all sorts of things, organizational, philosophical, and they're all based on a phenomenon, this pandemic, which has, in principle, only a technological solution in the first instance, but for it to be long-lasting, it needs a social science and humanities. So this is something that I also learned to value a lot in the Future Emerging Technology Advisory Group.
Thanks for that. Let's just stay with this question of social aspects a little bit. And there's one thing that I wanted to ask you, although we don't want to focus entirely on it, but obviously we have two outstanding female professors here who work in not just science, but also technology. And on the other hand, technology is often considered a male thing. I mean, Professor Laschi, what are your thoughts on this?
Oh, well, I must admit it is true. It is usually considered as a male thing. But of course, I cannot say why. If we look at numbers, at statistics, we see that it is quite true. It is true in the industry. It is true in the workplace. It is even true in students. So in the universities, when female students have to decide what kind of path to choose, we know that there are a few of them that decided for some technological hard scientific field. Of course, I don't have an answer, but I can just bring my personal experience in that. So when I was a student, it was really a male world. But as a professor now, I see that things are changing. And especially as a professor, I am in the biomedical engineering field, and the kind of robotics I do is BioRobotics, which means the biomedical application of robotics, but also the study of biological systems, like my studies about the Octopus. So there I see a much larger percentage of female students. So in biomedical engineering, we have an equal number of males and females in our classes, and also in our BioRobotics Insitute, we have a very large percentage of female PhD students and scientists. So that's just an observation from my side. It's not a real answer. It's not a real explanation of that. But I don't know, probably we know that a biological field attracts more women. If you go to a biology class, you probably find more female students than male students. So the combination of technology with biology or medicine is probably what attracts more women.
Yeah, let me ask a quick follow-up question then to both of you. I mean, and it's a bit provocative, of course, but do you think that women create different technologies or create technology in a way that's different from how men do it? I don't know, Professor Laschi, and then we switch over.
Well, it's difficult to say again. I don't know if we have a different feeling about technology. My own experience is that, as I mentioned in my group, we try to build robots that are more compatible with the society, more compatible with the environment. So we are quite sensitive to this kind of aspects of robotics, including the social aspects that Clivia mentioned, that I also think are very, very important, especially in robotics. There are so many implications that go towards the social sciences. So I personally have this kind of feeling, this kind of sensitiveness towards those topics. I don't know if it is because I'm a woman or just because I don't know, my personal cultural background, and of course my group has females and males, and we all go towards this kind of objectives. So I don't know if it is under my guidance or even the male scientists feel the same. Probably we have a little bit of more, we are more sensible to this kind of aspects a little bit. But it's not a real scientific answer. So as a scientist, I don't like to give answers that are not fully demonstrated, and these are not fully demonstrated.
That's entirely fine, Professor Laschi. I don't know, Professor Sotomayor, would you like to add? What's your take on this?
First of all, I really feel represented by many of the comments of Cecilia. I think this issue requires a great deal more study, because it's very difficult to generalize in this case. A lot has to do with a set of values, and many values come from socialization. It also comes and are strongly linked to the level of education and culture that one has received. And this question of values then tilts the balance in terms of competition at any cost, right? Or healthy professional competition to see which idea or which technology is better. It also has the factor that the funding agencies which are not state-run may use other parameters in the analysis and favor projects which they feel are safer or will be better managed. I think there are so many subtle aspects that would need a serious analysis from the social science and humanities, for example, that could unravel. First of all, I mean, I don't like this reductionism, but I'm afraid I was trained in that manner. So I reduced the problem to economic factors, psychological preferences, lifestyles, ability to plan, resilience, etc., and how this is projected and valued by those who would fund and therefore enable the research and the creation of technology. So I would really welcome a study that goes way beyond what has been seen so far of counting statistics and just looking at how these numbers move along the years. My first engagement in Women into Science and Technology was in Britain in 1983, and then in 1984 I joined the initiative of the Royal Society of London, Women into Science and Engineering. And it was an eye-opening, but you see, I look at some of the publications and listen to the debate nowadays, and it hasn't moved very much. It has not moved in all these years. And so we just see this incremental improvement on participation that will still need 100 or maybe 200 years, right? And in the meantime, we lose all the value that a different way of thinking, a different socialization could bring to new ideas, innovation, and therefore technologies.
Interesting. So we have one final question that actually feeds, I think, from that. Perhaps I'll start with you, Professor Sotomayor Torres. Many countries are trying to increase the number of female scientists and engineers, but they're actually finding it quite difficult to do this. So for you personally, why weren't you scared to study and enter into this field? And do you have any ideas for how females can be further encouraged to enter the STEM fields?
Well, my mother was a social scientist, and basically she said, whatever you want to do, what's the problem? And I said, well, people say family and career, of course you can do both. And so there was never a question.
Mm-hmm.
Do what you want to do what you're happy with, and surely you'll find a way to do it. And it was fantastic. And I just never doubted that it was possible. And there was another reason, this historic. I am Chilean by birth.
Mm-hmm.
And when I was making a decision on what to follow at university, it was a time of great political upheaval. And I went into physics because I wanted to help my country to be technologically independent.
Mm.
So there was this other motivation as well. Yeah.
Nice. And how about Professor Laschi, in your case?
Yeah, so in my case, I actually didn't consider this aspect much. I must be honest. So I took many elements into consideration in my choices, of course, but I never considered this one as one of the factors for making a choice about my studies, my future career. I must say that I completely disregarded it, but not because I was so smart to understand that it was not so important, but just because it was my nature. So I never considered it as a possible obstacle, or I never considered that it could have been difficult to work with men. Actually, I never thought about that. I had to do when some other people recommended me to consider that. Oh, but are you sure you're going in an environment with only men, or I mean mostly men? Are you sure? And at that time, oh, okay, yeah, I didn't consider that, but and this is something that it's very natural for me. I mean, again, I'm a person that considers so many factors before making a choice, but never this one, never the gender. I mean, the gender factor. So that's also my recommendation to young students, female students. I mean, consider everything you wish, but not this as an obstacle. Or I like very much what Clivia said about this feeling that women have of making a choice between a family and a career, especially in science, and that's completely wrong. I mean, we shouldn't think that we have to make a choice. So again, my recommendation is just follow your attitudes, your interests, your passions, because passion is very, very important in every job, but especially in science, in research. And passion should be the first one, but not gender related.
I would really like to thank you both for an interesting discussion. I mean, it was fantastic. And I wish you all the best for your future research. And yeah, thank you for taking the time to speak with us as part of Future Tech Week. We really appreciate it.
Thank you very much. And I hope we can both be, among the many actually role models that are available to the young scientists today.
Absolutely.
Thank you.
Thank you.
Thank you.